I should be back, and I seem to be connected to chat. Let's see. Someone type something into chat for me, just to make sure we are actually back. I seem to be connected again. This is going to be a very strange looking stream on Twitch. There's going to be 3 separate bits and pieces to it. So, okay, so let's see if we can continue from where we left off. Let's start RackAFX up again. Okay, and we'll load our project. Okay, so thank you. Everyone's back. Copper Beard, you're back. We're back rather. We've had a bit of a strange kind of incident where my keyboard seemed to go completely bonkers, although it wasn't my keyboard that was causing the problem. I kept getting the repeated letters everywhere, so we seem to be back okay now. So what I was going to do is just have a look and see what's going on with this code. So so here in Nanosynth, and here we are in the constructor. So let's just pop a breakpoint in the constructor so we're actually managing to start our project at all. Okay, let's go over here and hit debug. Go away Java update. So it looks like we're not actually instantiating our plugin at all, are we? I didn't expect this problem, must admit. So I wonder if it's because of this. The name should be fine, shouldn't it? So let's go and have a look at our RackAFX project. When I built a test project, I had a capital T in there. Let's try that for a starter for 10. Just try and change these to capital N's. I'm pretty sure that's not the problem, but go away. We'll give it a go. Fix all these. Let's have that music back. Do we still build? We're getting this one error over here, aren't we? I don't believe that capital N's got anything to do with it, but there we are. Okay. We're not hitting the constructor. I wonder if we've got to load it. Maybe we've got to load the plugin. Let's have a look. There we go. So that's now hit the breakpoint. So that was what the problem was. Okay, so I'll just press some keys on the MIDI keyboard. We've hit our breakpoint this time. Continue. Bring this up. So you should be able to see down here in the output window, I'm getting some reactions. I touch the keys, so that's actually working. That's a relief. I seem to be plagued by weirdness tonight, so that's a relief that that's working. Okay. Okay, so we've got our MIDI note on, so let's just copy the whole shooting match across and put that into MIDI notes off as well. And in here we get the same kind of things. We also get this all notes off thing. So we could actually just we can have an if statement around that, can't we? So this is note off. It's the same values as you get there, but what we can say is if all notes off, then we're going to trace just a slightly different message. Simply say all notes off. So Gareth Hubble, if you've ever watched his streams, has this thing with hashtag shambles. So that's what we've been tonight. Hashtag shambles. Weird things happening. I just hope it's nothing more sinister than a kind of a funny connection somewhere, or something that the state the computer's got into because it's been switched on all day. Because I don't like the fact it was typing its own letters. That's definitely weird. Okay, so the MIDI mod wheel, we can code that up next. So we can do similar kind of code, I believe. So let's copy this code, and in the mod wheel, I don't know if my keyboard's got a mod wheel. It's got a pitch bend wheel, but don't know if it's got a mod wheel. We'll give it a go. So this is going to be umod value. We're going to say here mod wheel. This is the modulation wheel. There's no note in this case, but there's a value. That should be %, not a 5. There should be value. Let's give that a guess. We'll put the pitch bend in as well, because I know I do have a pitch bend wheel on the keyboard. So we say pitch bend. This has got actual pitch. Oops. That. And the normalized pitch bend value. And normalized value. So normalized means it's put between 0 and 1 basically. DragonEye, one of them on the net found this solution's random key repeats. Apparently it's caused by Razer Synapse. Ah, right, I've got Razer. Closing Razer Synapse and reopening it was able to fix it. Okay, so that probably explains it, DragonEye, because I do have that Razer Synapse software, and I've heard it's well dodgy. And a lot of people have told me that although I use a Razer Kaio webcam, although the webcam itself is great, the Synapse software isn't that great, and that people have lots of trouble with it. So I think you've hit the nail on the head there. So switching off Synapse was the thing to do, I think. And if it happens again, we'll know to try that, and we'll figure it out if that's actually it. So let's debug again. I think we've probably got to unload. We got a failure. What happened? Didn't build. I didn't see what the error was. Let's build it. It's almost certainly my fat finger typing, which is duly famous on the internet now. No, it built okay, so let's debug. And load the plugin. Right, so this time we want there's a note on and off coming through. So if I just hit the very high C on my keyboard, note 84. There we go. I'm going to stretch across and bring the keyboard onto my lap. And here's pitch bend. There we go. That's the pitch bend wheel. So if you want to know what pitch bend wheels looks like, if we can try and get it on screen, it's this device here. And just the normalized value is huge. I'm not sure exactly what that's supposed to represent in that case. I thought a normalized value was normalized between 0 and 1, or plus 1 and minus 1, but that seems to be a very strange value. Oh, that's probably because it's a floating point number and I've actually put it down, so I think that needs to be an F, doesn't it? Let's try that again. Debug. Load. I'm not sure what that pop-up means, but there we are. Let's try the pitch wheel, bend wheel again. There we are. It's now between plus and minus 1, which is what I expected it to be. It's a floating point number between plus and minus 1. And that's when we talk about normalized values or bipolar values, that's what we're talking about. So it's that range. Okay, so that's those messages taken care of. So there's a whole bunch of other messages that a MIDI controller can send, and those are all captured in the MIDI message method here. However, at the moment, the MIDI messages will not come through because you have to enable them within our synthesizer plugin. So we need to go to our back into our constructor, and down here where we're doing our initializations, we need to set it so that we can receive all MIDI messages into the plugin. So there's a member variable which is called something like want all messages or something like that. So let's have a look. Want all MIDI messages, and we set that, that's a boolean, we set that to true. And that means now we're going to receive into the plugin all the MIDI messages that our controller can send, and it can send quite a few. I've not experimented with all of the things it can do. Probably won't do much with that, but we'll wire all the messages up anyway. So MIDI message, there we are. Okay, so the kind of things that come through in the MIDI messages, there are control messages, and there are things like stereo panning and your pedals, so your expression pedal and your sustain pedal. I haven't got any pedals connected to my my keyboard. My wife's keyboard's got a sustain pedal, and I'm looking at buying some Roland pedals to go with this keyboard. So when we get those in, we can try those out. There's also pressure sensitivity that we get. So let's have a look at what messages we can process. So first thing, we need the same bit of code, the same guard clause that we've had all along. We're going to put that into our MIDI message method to make sure we don't process messages which aren't meant for our channel. In this case, the channel is coming through as an unsigned character rather than a uint, so this needs to be C channel, like that. And we need to cast that as a uint. So one way to cast would be to do this. However, that is not the best way of casting in C++. So I'm going to say uint uChannel equals static cast uint C channel. And just put that in there, and we can make this an auto. And I believe if you hover over it, it is a nicely cast uint now. So that's the safer way of doing it. It's a better cast. Yes, so the vibrato on the pitch stick, if you move it left to right, yes, that's exactly what it is. So it's a frequency modulation rather than a tremolo, which is an amplitude modulation. So we're going to have all those features in our synth. And when we've finished wiring up the MIDI messages, I'll just do it before we finish. I'll just safe safe in C++ feels enable. Yeah, this is just the modern way of doing casts. And I guess it's you can perhaps explain to me why we've gone from the C style casting which we use in C++ and C to this model of casting here. But I'm trying to follow best practices as I understand them with C++, and I will need correcting on many occasions as I'm not a C++ programmer. I'm still very much learning. Okay, so we get got our guard clause in place. Now we get an unsigned char, which basically the unsigned char is basically a byte, isn't it? So we're getting a byte in here, which is saying what our status byte is, what the message status byte is, and we get to a C data 1 and a C data 2, which are 2 bytes of data that come along with our message. So let's go and have a look at. So we're going to go to d:/. RackAFX documents MIDI. This is the complete detailed specification for MIDI version 1, and it's very extensive, 334 pages in length. I'm sure it's fascinating reading. I've skim-read some of it, and it's got lots of interesting things like we're going to be coming across. When we worked on the Synthesizer project, remember that we did ADSR. Well, we're going to be doing the same thing in these projects. We're going to be creating an envelope generator. So it goes into all that kind of stuff, but then it talks about MIDI messaging. Circuitry. Yes, so basically here we get data bytes and data bytes, and then we get the different types of messages, channel messages and system messages. So these are the kind of things we're dealing with at the moment, rather than simple messages like note on, note off, etc. So you're saying that okay, Phil Saber says C-style casting allows all styles of casts from very unsafe casts to safe casts. C++ casts are much more specific. Okay. So it's like a templated cast, right? Okay. They're searchable. Okay. Yeah. So here what we say, so a single message can contain a status byte and a data byte, or a status byte and 2 data bytes. That's why we're getting this structure. And for a system message, you get a status byte, a data byte, and then this EOX, which I'm not quite sure what EOX is at the moment, but it's an exclusive message. It says end of exclusive message, so it's just a terminating byte. Okay, so we understand why we're getting this this kind of data. On your channel you get your status message and then any data attached to it. So we're going to want a switch statement, and we're going to want to switch based on the status that we get. So do a switch, and we're going to switch on C status. Okay, so the first case is going to be so we've got a lot of these status messages are set up nicely for us as enums in that's synth functions, and one of them is polypressure. The first message we're going to look at, polypressure. So we'll just put that in place, and then we're going to have okay, so that is polypressure is so what's polypressure? I think that is basically where it's for polyphonic touch sensitivity. So let's get I'm not sure we're going to be able to demonstrate that we're receiving all of these messages, but we'll see. Okay, so this is polypressure. And it's going to be, so we're going to get for that we got a note. So the data one is going to be the note. This is C data one. And then it's actually going to be here the value of the pressure. That's going to be C data 2. So I've just got a copy of the specification down here. I'm just trying to quickly read it. So what we're going to want to do is to cast these C data 1 and C data 2 in a similar way here to uints. So we want a U data 1 and a U data 2. C data 1, U data 2, C data 2. So the next one. So there's a whole range of MIDI messages we can receive which are control changes. So they're coming from, there's a whole range of buttons, and all the keys have assigned control values actually. So you can use function keys on the side of my controller to apply a function to any of the actual physical keyboard notes. So we need to look for control change. I think it's called control change. I think the names of the messages so I've got should match up with the names in the E number. They do. Okay, so control change. Okay, so there's lots of different kinds of control changes, and they're basically controlled by the value of C data 1. So we get a control change status byte come through, and then there's lots of different types. So we have another switch statement. This is going to be on C data 1. Okay, and the first one is a volume control. So case, and it's volume control 07 is the code for it. I don't like the way it's laying out this switch statement. It seems very bunched up. It's not indented nicely for me. So this is volume. And basically it's got a channel and a volume value. And that value is going to be in there. And the next one is pan. This is the stereo panning, and it's pan control 10. And we want to get the value of that as well. Pan, and it's exactly the same. I'm going to do a case on, now it's the expression pedal. Expression CC11. So expression pedal. So I haven't got one of these, so we can't try it out. So the U data contains the value that's coming through from the expression pedal, basically. Then we've got the sustain pedal. Sustain pedal. Okay, so it's a bit more complicated than that actually. Let's leave that in here. So looking at the code, It's saying that we get so sustain is a value that whether sustain is on or off is actually determined by the value of view data being greater than 63. 63 is a funny number. Okay, so basically what we've got, we're gonna have auto sustain on equals U data 2 greater than 63. That should be a boolean, yeah. And so what we can say then we can simply say if sustain on else that. So we can just pull this up and we can say send pedal on and sustain pedal off. Okay. So we're missing our break commands, aren't we, here? All the break statements in. We get this to actually try and format the document a bit nicer. Okay, so what's next? Let's have a look on the MIDI. So there's an all notes off case, all notes off. Put our break statement in, so we've got it there. So we don't need to do all notes off. We already handled that actually up here. All notes off. Handled it in the MIDI note off, so we don't need to physically do anything about that, but we'll actually have the case in there. And then next there's a mod wheel. This is the same story. We're already coping with mod wheel, so we don't actually physically need to do anything. We'll just break at that point, but we've got a place where we can put code later on if we need to. Then we can just put a default. For default, we can try and trace something, I guess. We can say okay, so there's a reset all controllers. What should we call this? It's just a control. Control number will be %D, and that'll be udata2. udata1, sorry. So we'll just log that. I'm not sure what to do about if it's reset all controllers. What we'll do is we won't log anything if udata1 is not equal to reset all controllers. Reset. Have we got it in here? Reset all controls we have. Then we'll do this bit, otherwise we'll just not trace anything at all. Okay. Alright, so that's that control change. So where's that line up? That lines up on that line there. So the next thing it could be would be a program change. The case program. This is the programmable aspects of your MIDI controller. So if it's a control change, then we'll put the break in. Pardon me. And then we can do this again. So program change, channel, and the value of that is going to be, so we want number, %D, and value. So that's just going to be a program number and a value that's been input into the program. And then there's channel pressure. So you've got poly pressure, which is your polyphonic pressure, and then you've also got the channel. So this is a less this is pressure sensitive across the entire MIDI channel. I'm not sure what that comment's meant to mean. You don't want to be in chat, just go, you know. So channel pressure. So this is one where we don't have a udata2, so we can just copy this down. I'm trying to read the specification at the same time as doing this, so you know, cut me a bit of slack in there, please. And then we can have a default on that. The way this is lined up, I'm not convinced. Default. For this one, we must start with, if it's done default, we won't do anything. So let's just see if we've got all our brackets lined up, because I don't like the way it's formatted that at all. I'm feeling there's one too many curly braces in there. I think that's right there. Maybe that's wrong there. You sometimes use braces as cases, yeah, not just use variables. I'm missing a brace now. So let's just, so that's that if statement. There's the start of the switch. Should I really have these kind of problems? Let's see if we can make this a bit more readable. Okay. So that is, there's the opening brace there. Definitely missing a brace, aren't we? If it was formatted so I could actually read it properly, it would be a lot more helpful. Now, I think there's a problem. No, that's not a problem. That's fine. So there's the open and close for that. All notes off. It's fine. Mod wheel looks okay. Default looks okay. We've not closed that case statement off. So that would be the control change. I think that's it, isn't it? So there's a brace there. Doesn't need to be a brace there. Open switch. That doesn't look right though. Return true here. Should be the last statement. Here. Try building that. Double-ended braces, yeah. It doesn't help. Oh, what's it? Why won't it link? This is where I get. Why won't it link? Can I open the file nanosynth.dll because it's not building presumably? Right. The switch statement looks okay, does it? On the face of it, it collapses nicely. We've got poly pressure, control change, program change, channel pressure, default. Let's just go through the documentation. So the poly pressure, and then you get control change. So poly pressure is simply, if it's poly pressure, then print something out and break. If it's control change, then we've got a case within that, a switch statement within that. We're switching on, it looks like data 1. So then we've got volume, pan, expression pedal, sustain pedal, all notes off, mod wheel, default, and there's a extra brace there. Is that it? And then we get program change, channel pressure, and default. Let's try building that. Yep. Thinks I'm defining a local function. I can't understand why writing a switch statement is causing me so much trouble. Do we get any more helpful indentation in this version? So there's That adds up. That adds up. That's okay. That's okay. That's okay. That's okay. And then hi Fluff Creations, welcome to stream. I've got an inner switch, one of the cases, do not see that, yeah, that's a problem. There's switches within switches, so that looks okay, the default, and then that should match up with that. And then we've got default there, we've got channel pressure there, we've got program change there, and then that brace should match up with that brace. Who would think that a switch statement could be so difficult to deal with? Okay, well it looks okay to me. So why will it not? Oh, it's got a. It thinks that I've got a local function down here. So my braces don't add up, but I can't for the life of me see why on earth they don't. Because if I collapse these things down, there's no. Okay. That's collapsed all the way, so there's actually no. So it's almost if it wants that, and then that obviously has to go outside of the. Let's see what that does when I collapse it. Let's try building that. Can I open? Cannot look in. So it's not building, is it? Why isn't it building? A game dev stream with 130 viewers. That's fantastic, isn't it? Wow. What are they building for your Snowball that's attracted that many viewers? What's that doing there, though? That's what my question is. What is that? So let's start commenting stuff out. That's the easiest thing to do. So let's comment all this out. Do a rebuild. That still doesn't like it. Let's see what we can say with a clean. It won't link. So anyone with any experience of C++, give me any clues about why we're not actually linking. I don't really understand why we're not linking. Let's comment everything out apart from what was there when we started. So even though I've commented that out, it still doesn't build. Doesn't link, that is. Because there's something else I've done which is it's complaining about. We did the pitch bend, and then we came down and did this one. We demonstrated pitch bend working. No, it doesn't want to link. I'm not sure why. As far as I can see, we got the same codes we had before now. Message, blah blah blah. Everything else is commented out, apart from return true. I'm going to shut down Visual Studio and start it up again. I'm wondering if I had the project loaded. Into RackAFX. Let's just see if that theory can be shot down in flames. So that now builds. So I think I was right. I think we were actually had loaded up, and the DLL couldn't be overwritten, couldn't be linked. So let's start uncopying. Let's start by doing it all, in fact, because I think that breaks that switch statement. Looks okay now. Okay, so let's uncomment that lot and try building again. The file was locked. You're absolutely right, Fuel Snowball. The code was fine. The file was locked. It was locked because in RackAFX I had it loaded. I needed to unload it before I could recompile it. So thanks. I haven't got my bot running today, so the hey command would have been the right thing to do at that point. But as it's not running, it's pointless. So okay. So let's see if we can get any of those messages to come up. I'm not sure if we're going to be able to get any messages to come up for those control messages, but we can try it. So we'll debug. And we'll load the plugin. So can we get some MIDI messages? So we got some some note on, note off. We got some pitch bends. Reach across, get this keyboard onto my lap again. Oh, there, a program change. Look, program change number 1, 2, 3, 4, 5. Yeah, so we got those. I've got octave. Octave changes. And that's not roof string. Got a function. So here's some. There's a volume change, so that's a control change again. This time it's from a knob that I've got. There's another one. So we're picking up the program change, different values are there. Actually, it's interesting, some values in there. There's pitch bend coming in, all kinds of stuff. Control changes and program changes. So we're picking up, I've actually got this thing called a laser harp as well, which I can't get to actually switch on at the moment, but that should give us some interesting kind of pitch bends and modulation changes. So it looks like all those MIDI messages are now actually being recorded, which is great. So let's stop debugging. Let's remember to unload the plugin. So one of the reasons we've moved to RackAFX is because of this rapid prototyping system we've got, which is with all these GUI controls. And what it enables us to do is to set up loads of kind of switches and sliders and volume knobs and all that kind of stuff really quickly. And we'll do that next time. But what I wanted to just do before we wrap up, because it's we've been going for what, 2 hours now, is it? On and off. Can't really tell because of the weird nature of this stream. It's all split up into different segments because of the problems we had. Seemingly with that Razer side of that software. What I wanted to quickly do was, if we can bring up OneNote. Let's see if we can do some drawing. Can I draw on this? I can. Okay. So the project is NanoSynth. So what we're going to do with NanoSynth, we've got the basic structure now built. So we've got it compiling. We've filled in some data on the MIDI messaging. We're logging that MIDI messaging. Now it's actually time to build some things that make sounds, and we'll start doing that from tomorrow. And NanoSynth is going to consist of 2 pitched oscillators, it's going to have 2 pitched oscillators, so this is what's going to create our sounds for us. And they're going to be slightly G-tuned from each other. They're going to be, I think it's about 50 cents, half a semitone, something like that, or even 25% of a semitone detuned from each other. And what that's going to do is give us a nice rich sound. And these are going to be analog models, so analog modeling oscillators. Analog models, and they're going to be what's called BLEP, and we'll come into what BLEP is. BLEP oscillators. So the way the problem with having mathematically generated oscillators is that if you think about I don't know, a sawtooth wave, the profile of a sawtooth wave is like this. That's supposed to be vertical, and this vertical line where it drops suddenly from 1 down to -1 in value. I'm terrible at drawing, aren't I? That's +1 to -1. That's a vertical drop. It's not actually a line there. It's actually this ramps up and then suddenly changes from 1 to -1, then ramps up again. This discontinuity that happens here causes massive aliasing, and we'll talk about what aliasing is, but it's basically bad. It's fine for a low frequency oscillator using it for control, but if you actually have to listen to this, you get lots of frequencies generated which aren't real. You don't get just the harmonics, you get everything in between, and we'll try and demonstrate that when we get an oscillator working. We'll switch into into the kind of what we might call the trivial saw wave, which is the mathematically generated saw wave, and the mathematically generated square wave is the same. With a square wave, you kind of got the signals actually look like this. And note what we normally draw is a vertical line here, but they're not really there. It's actually suddenly instantaneously jumps from -1 to +1, and then goes up at +1, then jumps down to -1. And these points of discontinuity cause real problems with aliasing, and we need to get rid of that. This BLEP method, which stands for bandwidth limited step, is one way of doing that. And what we're trying to do is basically make these edges smoother. So it's kind of putting a profile on it like that, so there's no discontinuities. It's hard to draw. Okay, so that's what an analog square wave or analog sawtooth wave did. It wouldn't have this jump, it would actually curve down and it would be kind of smoother. And we're going to kind of use yes, it's like lerp, yes, but there's the technique we're going to use is called BLEP. There's two ways of doing it. There's one where we kind of work out or estimate what this curvature is going to be using a polynomial, and we're not going to go into the maths of it. And there's another way where we actually calculate an edge, a smooth edge, and insert it into the waveform. So our pitched oscillators are going to be advanced oscillators. They're not going to be like the ones we wrote in the synthesizer project with C#. They're going to be proper industrial strength, as it were, pitched oscillators. We're going to have in our synth, our test synth, nano synth, we're going to have one LFO. LFO stands for low frequency oscillator, and that's going to oscillate between, let's say, 0 and about 20 Hertz. And that's going to be used to modulate the pitched oscillators. So it's a control signal, and those are going to be mathematically generated. So there's going to be a sine wave, which is mathematical sine wave. There's going to be a square wave, which is generated for a mathematical formula, and sawtooth waves and all kinds of things like that. There's also the noise, pink noise and white noise and things like that, and also some features which we didn't have in the C# synthesizer. There's a feature called hold, where we can kind of hold random values for a period of time, and also our square wave oscillator up here. When we have this, is going to have lots of different waveforms. We're going to be able to manipulate the pulse width of the square wave. So whereas we're used to looking at square waves and they're all kind of regular, what we're going to be able to do is to have square waves which look like this. So they stay kind of positive longer than they are negative, or vice versa, and that's called the pulse width. That there is the pulse width. So we're going to be able to manipulate that. So we're going to have one LFO. Say it's in the subauditory frequency range, 0 to 20 Hertz, and that's the controller. We're going to have what a digital version of a Moog ladder filter. So that's going to be our kind of low pass filtering mechanism. So that's something we haven't looked at before, and we're going to have an envelope generator. If I write normally, this is actually reasonable, isn't it? So, and this is going to be able to generate amplitudes, we're going to drive it from a filter, and we're also going to be able to do switch envelopes. So it's going to be a reasonably advanced little synthesizer when we're finished. It's going to have these features. It should give us nice variations of sound. We'll be able to build a plugin out of it, put it into a digital audio workbench such as Reaper, and then we're going to be able to put our own other plugins. So we're going to put our Dimension chorus effect into that and use that, and we can build other effects. So rather than the approach that I took with the synthesizer for C# and .NET Core, where we built everything in, we're going to be able to, it's going to be kind of a pluggable architecture. So the source will be our synth, and we plug in our effects afterwards. So this is the first synthesizer we're going to build, and this is what we're going to. So this is number one. This is going to be a test bed. So we're going to build all our reusable C++ classes and objects in this and test them, and then we can reuse a lot of these features. Now our oscillators here, we're going to have BLEP oscillators, but we're also going to have the option to switch in wavetable oscillators. Oops, let's get rid of that. Wavetable, so we can compare them. So when we say with Fuel Snowball's comment that we don't really need them, our CPUs are powerful, sure, but let's see if we can detect any audible differences between them. We're also going to be able to experiment with different versions of BLEP. So there's this polynomial approximation for the BLEP, the wave shaping that we're going to be doing. There's also the option to actually do more sample points either side of the discontinuities. So it's fairly interesting stuff, and I want to keep it kind of programming based rather than mathematically based. But this is the first one we're going to do this, and we're going to build on this. In the project book, there are a number of exercises which you're given, which to extend the features. For example, on the LFO, there are a number of kind of features we can build in there to make it a bit more advanced. One of the things that the LFO is going to do for us is give us some frequency modulation, which is like your vibrato. And what happens with, especially with singers, they don't apply vibrato immediately. So they'll hold a note, and after a short while, they'll start to apply the vibrato to the note they're holding. So it starts pure, and then the vibrato comes in. And we want to be able to control that with our LFO, so have a kind of a delay or an attack time. So we say how fast and how kind of hard the vibrato effect is going to come in. I'm not sure how we're going to do it. It's all part of the exercise. I hope we're going to learn as we code the oscillators in the next stream. At least we start the coding of the oscillators, and that we'll get an idea of how to do a lot of these things. But the reason why we're using RackAFX is that we're going to have a nice GUI on this. We're going to start off with a very simple GUI, which is going to be the built in the rapid prototyping system, and then we're going to actually create a custom GUI. And just to show you what the custom GUI can look like, if I bring up Reaper, here, and let's I don't know, let's find a let's insert a musical instrument. We'll insert real synth. Okay, that's that, and I can add in an effect now, and I've got a Codebase Alpha effect here, which is Dimension Chorus. This is the one that we built on stream. I think it's the last effect that we built on stream, but I've actually just transferred that across into RackAFX, and I built a nice little front end for it. So this is the front end, and we've got some nice knobs, and they've got nice labels which are already built into it. You didn't have to fiddle around with grid layouts and all like that. And we've got the values down here. Okay, and we've got a nice logo, and it really looks the part. So this is the bit. This is the plugin here. The rest of it, the chrome that's around it, is being provided by Reaper. So I think they look really nice, the front ends that you can generate on RackAFX, and there's virtually no work, it creates itself. These are all drag and drop components, and there's lots of different styles. So these could have been sliders, we can have push buttons, we can have all kinds of things in there. So I think that would be really nice. So that's why I've switched over to RackAFX from Juice. Is that I don't know about you, but I'm not someone who finds creating user interfaces particularly interesting, which is why I was extremely grateful for FuelSnable for helping me out with his design skills when he created some knobs for the WPF synthesizer. Because it's just, to me, it's just I'm not interested in GUI that much. It's nice to have it actually created for you. So that's why we've gone over to this new kind of framework. What's the time? It's 10 to 11. I think I'm going to stop there. After the stream, I'll fix up Git so that we're connected back to our Git repository, and I will load all this up into GitHub. So if you don't know, GitHub is here. It's my GitHub. I've got about 31 repositories up there. Some of them are forks and of other people's repos, but I've got a fair number of my own projects. So NanoSynth will be up there shortly after the stream ends, and hopefully you'll be able to download it and have a play yourself. It should, at the moment it doesn't do an awful lot, but eventually what we'll have, as well as the RackAFX code in the repository, we'll also put the complete project to build the VST3 plugin from scratch. So you won't need RackAFX in the end. We'll actually have all our objects will be completely portable, and we'll build them in to an auto-generated plugin for VST, which uses the native SDK. So there's no parts of RackAFX will be in that. It'll be pure VST code using the VST SDK. So you'll be able to kind of take that, and if you're a VST programmer, you'll be able to kind of play with that. So there'll be lots of ways we can attack this in terms of sharing the code and changing it. Okay, so thanks everyone for being extremely patient with me. We've had some very strange issues in this stream, and never quite come across that issue with the repeating characters appearing everywhere, and it has meant the stream has been broken up into 3 segments, and I'm not really sure what to do about that. It's a weird and a great stream. Thank you very much, Dragon. I really enjoy this stuff. I'm not going to drag in huge audiences with it, I don't think, but that's not really the point. People like yourself are interested, and I think it's got some interesting aspects to it. And as I say, there's that kind of very primal thing about making your computer generate sounds, which I think I really enjoy. It's something we did kind of way back when we first got kind of personal computers. Making beeping sounds was great. Okay, so let's see if we can find a suitable person to raid. Let's go over to my Twitch. Let's see who's available. There's up the Michael Jolly's up there, so let's go and raid the Michael Jolly, shall we? So do stay with us if you want to join his stream. It's a very, very interesting and fun stream. So thanks for Weetol. I've made a Twitch chat bot, Weetol. I've got a very extensive Twitch stroke Slack stroke Discord chatbot. It does all 3. It's also got my adventure game in there, which is what we sometimes work on. So yeah, I've done all that. Old hat for me. So thanks for joining me, everyone, and do enjoy the raid. So we're going over there very, very shortly. in 1 second time. So take care everyone, and I'll see you tomorrow. Bye bye.